Welcome to StreamDetroit. It's an odd one. I'm off camera. Brad's in the hot seat with Jon Rimanelli from IFlyASX.com. Welcome to the show.
Hey, thanks for having me, and great to have you guys here on site here at our facility at Detroit City Airport. This is our design, engineering, and prototype center where we are manufacturing vertical takeoff and landing aircraft to move cargo and eventually passengers between cities, airports, and suburbs using ride-hailing technologies, so you can essentially skip traffic.
I love it, and so I know that this is a phrase that you probably don't want to use, but what I'm hearing is the flying car. But let's not go there. But let's talk about.
I was told we'd have flying cars.
Where are the flying cars? So it's not flying cars. So tell us a little bit about, before we dive into that, because I know it's an emerging segment and it's really exciting. A lot of companies are talking about it. How the heck did we get here right now? We're here at City Airport, right? Yeah. And that's where your global galactic headquarters are. Mm-hmm. So tell us a little bit about your background that got us here to this crazy place with this amazing machinery and prototypes and carbon fiber and so on.
Yeah, awesome. Well, Brad, first of all, we don't build flying cars. We assemble car parts so you can fly. And that essentially is how we arrived here. It's been over 20 years as a contract manufacturer of automotive electronics, mission critical electronics, everything from engine controllers, proximity sensors, any electronic device in a vehicle we have at some point in time prototyped or mass produced. And it occurred to me when we started growing our business to the point where I was just tired of sitting in traffic and staying overnight places that I should get into aviation. Bought my first airplane and learned how to fly.
So you're a pilot.
Mm-hmm. So awesome. I am a pilot, and just kind of really started feeling bad for everybody sitting down there in traffic as I was sort of flying over them. I'm like, man, it would be really sweet if everybody could do this. It's just a big shame because the United States has got over 15,000 of these airports, and the mass traveling public, some 1.5 billion people, are enplaning within the top 150 airports in the United States. So that was really sort of the bug. I saw a gap in air transportation and truly an opportunity to democratize the way people and products move by taking a serial production approach to building aircraft systems, sustainable aircraft systems that leverage distributed electric propulsion. So yeah, we're here. We basically started in automotive, sort of saw a lot of the technologies in connected vehicles, autonomous vehicles, electric vehicles, and really what we saw as an opportunity to integrate those components and systems into aircraft that could elevate traffic. And that's really where the vision began, is integrating those components and systems and integrating the mass production process toward the production of aircraft systems.
So that's kind of the connection, right, to Detroit. At first glance, you're like, why the hell is an aircraft company in Detroit, Motown, right? We're a city of cars. Yeah. But it's that infrastructure to a big degree, right? So whether it's engineering, whether it's manufacturing, mm-hmm. it's electronics, it's components. Yeah. And
it's a great ecosystem, right? It's a very mature ecosystem of, like you said, skilled labor, talent, technology, production, which to me makes a lot of sense.
Cool. And how did you, just as a side note, but related, how did you guys end up here at City Airport?
So when I bought my first airplane, I kept it here and really sort of started scratching my head as to why it's so dead. And not unlike the majority of airports in the United States, general aviation has gone through an economic cycle and it's very depressed at the moment. So I ended up here and starting as a pilot, and really in 2008 really just decided to make the jump to aircraft production. Started my first company in the aerospace business Detroit Aircraft in 2011, started building drones. We actually partnered with Lockheed Martin, built over 55 aircraft for Lockheed, our defense and commercial grade drones. Really was our first foray into building aircraft, nothing like starting small. You know, these aircraft were, you know, they folded up into the size of a football, could be launched within a minute, can, you know, fly a mile or two out in the dark at night and see through fog or smoke. And
with cameras and sensors
you know,
and
thermal
imaging.
cameras, and did, you know, search and rescue type activities or surveillance type work. And so that was kind of how we ended up here. We turned this facility into a production facility. We built all those aircraft here, and you know, and sort of evolved from that to building, you know, much larger and larger aircraft systems.
And that's a big jump, though. So talk a little bit about that. You know, that aha or eureka moment where you said, you know what, we're doing these. So you've kind of proven that you'd proven that out through military, through, I think you've also worked with cities, utilities, municipalities, and so on for in camera rigs. So maybe some Hollywood.
So you know, at the end of the day, these small unmanned systems, also known as drones, can be used for a variety of applications, from, you know, precision agriculture to surveillance to search and rescue to infrastructure inspections. And so the platform itself is pretty, you know, dumb. It's without a sensor, and depending on the sensor, you know, that dictates what job the vehicle will do.
Remote controlled, right?
Yeah,
so it's
so-
remote controlled, so not autonomous, and that's so there's kind of two big leaps. One is the scale, the physical size, right? Moving from that size to, you know, what you're going to be carrying people and things that I assume maybe cargo and such.
So
would
we'll start with cargo, and so yeah, there's a big difference. Obviously, the energy density of and the quantity and a battery, and the power density of the electric motors is very specific. Electric motors. So there was an aha moment. We started sort of doing the math, you know, back in 2012. Like, man, it would be cool if we could build a drone big enough to move people, because I sure as heck would love to skip traffic. Wouldn't that be great?
Right.
And problem was the motor technology wasn't there, the battery technology wasn't there. You know, lightweight materials were certainly becoming, you know, very popular with composites, but not really a serial production approach to leveraging composites. There is now. We found some motors and controllers and batteries that could do the job of demonstrating vertical takeoff and transition flight back in 2014. And after a number of years of lobbying the company to sell us motors, we finally got our hands on these motors that, you know, are, you know, they're world class.